what I have on tap for today is, okay, first there were a couple of things that I wanted to just sort of mention. Uh, just a couple of just miscellaneous things. One involving Booleans, and the other is to clarify something about what happens inside of a method when you call a method and pass an argument in. What happens to that? What goes on with those arguments? Because it's a little tricky. With languages that came before Java, there were many more things that could happen. And Java took the experience of these other languages and said, well, there's really one best way to do that. And so Java chose what I believe is the best way to do that, but it's got a few little gotchas. And then we'll get to kind of what the main topic for today is, which is about these collections. Now, okay, so we'll get to that. So the first is, and I've noticed this in some of the code, and again, not to kind of point. Here's the thing about Boolean variables, and this applies across the board, whether you're doing Java or JavaScript or Python or anything. The reason to have Boolean variables and Boolean expressions is to use them as Booleans. So for example, if, and it's not that there's anything wrong with it, but if I have a Boolean variable called X, and I'm doing a test that says if X is equal to true, that the purpose, it's much better style to simply say if X, because X, these are exactly the same. It's kind of a stylistic thing, but you say, well, what difference does it make? Not a whole lot. The main difference is that it makes, it has to do with this. Each one of you is going to be writing a thesis at some point before we parole you from this place. And in your thesis, you're going to be writing in English, hopefully. And the English that you use will hopefully be, technical English that is, how should I say, mature, as it were. So there is English that you could use that would be grammatically correct, but look like it was written by a sixth grader or third grader or something. In other words, there are things that there are grammatically correct things that little kids write that are technically correct, but if you read them, you say, well, this is obviously written by a kid and not an adult. So that's kind of what's happening here. In other words, this kind of thing is, while technically correct, is not, how should I say, it's not good style. Okay, so I mean, as an example, in the let's make a deal problem, in really the way to write the winner function method is something like this, rather than kind of going through a lengthy if this then that, etc. In other words, this expression, this is a Boolean expression which is either true or not true, and this is the cleanest and most clear way to express what's going on. So anyway, so this is again, I just want to make sure that when you use Booleans, use them as Booleans and avoid this kind of thing. Okay, the second thing, and this is a little more subtle. When you invoke a method and pass an argument, then what happened? What is the relationship between what goes on inside that method and what goes on outside the method that called it? And here's how to understand that. The term is is a copy of the value. Okay, what does that mean? That means that when I call a method and pass it a variable, it makes a copy of that and uses that copy within the method. Remember, I sort of had these rants about scope. The scope of that copy is just within one of those method calls. So as soon as you return from the method, that copy goes away. Now, I mean, I could just sort of leave it at that, but the subtle thing is that, and this is something which is not necessarily true of all languages, but is true of Java. Inside that argument, if I change that variable, it does not change the one that called it. So if I have a variable x and I invoke a method, and inside that method, it takes that argument and changes that value inside the argument. Again, that's actually not very good style, but that's something that's possible and something that you sometimes want to do something like that. And I return from that, you may think that the variable that you called it with has changed. And the thing is that it hasn't, because a copy of the value was passed in, that copy was changed, not the original one. Okay, that's a good thing to think of for primitives. For objects, it's a little more subtle. That but it's still true, and it's important to understand what is an object here. An object, what we've been calling an object, is in fact it's a one-word reference, meaning that when we have a variable that's a type of object, that's actually a slightly incorrect way of describing it, because that variable does not contain all of the stuff in the object that you might think it does. In fact, it's just a reference to a place in memory that has all that stuff. So now, what is that stuff? Well, it's basically two things. One is instance variables. So each object has its own copy of the instance variable. So how do you do that? Well, it's somewhere in memory. So what this quote object variable is just a reference to where the virtual machine can find all that stuff. Okay, so here's how we can apply this copy by value thing to that. When we call a method with an object as its argument, that reference is copied. And so inside that method, if that copy of the reference is changed, then the method that called it does not change, does not point to a different object. But here's the little thing on that, is that because it's a copy of the reference to the object, if I invoke a method on that copy, then it actually does change the state of that object, if that makes any sense. Okay, so that's kind of, it's an important thing to understand when things don't go exactly the way you think they're going to go. Okay, so those are just kind of two little Java things I wanted to make sure that were made clear. And yeah. Okay, so now you may have noticed that in the blackjack.
One question real quick, just on what you were saying before. So when you pass in that reference, the only way to change it is with, that's why we have our setter methods, right?
Well, yeah. The only, if you follow the rules of encapsulation, which is to make all of your instance variables private, then when you invoke a setter method and pass in a value, what happens is the the setter will make a copy of the value that gets passed in, and then assign that copy to the variable that it is. So if it's a primitive, and I pass in, let's say I pass in a variable that has the value 3, it will make a copy of that variable, which still has the value 3, and then in the setter, it will assign that instance variable to 3. If it's an object, again, it will make a copy of the object, pass that copy in, and then assign the instance variable to that copy of this reference. But that reference is pointing to that object, to where that object stuff is. So now that copy, which has now been assigned to the instance variable, is now in fact pointing to the object. Does that did I answer it?
Yes, sir. I just want to make, that's what the slide is about, right?
Well, it's not so much about that. It's about understanding what goes on when you pass in the method. Let me try to, okay, so since you, let me try to
Or
give
is this, I think what you're talking about is like when you put the return, if you wanted to change a primitive, like if you passed in X and you wanted X to change in something else, you'd pass X back in the return, right? And that's what would change it.
yeah, something like that. Yeah.
Okay. I don't know if that's what Josh is trying to get to.
Well, yeah. Let me. Here's how. Let's say that you wanted to have a method that swaps two integers. Okay, I mean, you've all seen what the swap thing is. And just applying that, and I noticed that actually I was pleased to see some of you use the swap thing in that let's make a deal assignment. Okay, so here's a method. Say, okay, I want to write a helper method when I want to swap two values, let's say two integers x and y. This is the logic that swaps them, right? So let's test that out. So okay, so here's A and B, and I want to, so let's okay, so there's A and there's B. Okay, so clearly what's intended here, like if I see something like this, oops. If I see something like this, then the intent is that when you call this, the values of A and B should be swapped. In other words, after this call, it looks like you think that A is going to be 5 and B is going to be 3. Is that, do you kind of see how that is the case? But when you run it, you see that after you swap them, they haven't changed. And so you think, well, is there something wrong with the logic? No, there's nothing wrong with the logic. In fact, if we run the debugger and we're in here, so here's x is 3, y is 5. Okay, temp is 3. Now, X is 5 and Y is 3. And then we step out and we see that they haven't changed. So what happened? What happened was when they were called, a copy of A and a copy of B were made. Then all this did was change the copy so that when it returned, A and B were not affected. Okay, does that's what this is about. Okay,
That makes sense. That helped clear it up for me. Thank you.
yeah. So, and the thing is that it's unfortunately just all too easy to kind of to make that mistake if you know, and when something strange like that is happening. So I'm calling a method and I'm expecting something to change and it's not changing, then one of the reasons why it might not be changing is that I'm expecting my arguments to be changed inside the method. And in Java, that simply cannot, that's not the case.
So in order to change it in that method, would you have to write this dot X?
No, I mean, well, the thing is you can't do it this way is the bottom line. If I wanted to do something like this, then I would have to do it basically inside. And the reason why it worked for those of you in the Let's Make a Deal that use the random shuffling and the swapping, the reason that worked is because you were using it on an instance variable whose scope was throughout the entire object. Remember, an instance variable has scope throughout the entire object. The scope of these arguments is just within one call of this method.
So while you have NetBeans up, could you show us how to use the debugger?
Okay. Okay, so first of all, to set a breakpoint, there are a couple ways. One is if I right click on a line, I can choose toggle breakpoint. Oops, why was that here? If I'm on this line, I can say toggle breakpoint, and that kind of toggles that way. Or I can just, if you click in this place where the line numbers are, we have that. And so if I right click, then in my main method, and I choose debug file, then it will run to the breakpoint. And then I have these little controls up here. This will step over. So step over just says, okay, I'm going to step over it. One typical use case. So here I'm sitting about to call this method, and I want to see what's going on inside of it. So see this little arrow? It's called. It should say step into. So I click step into. It takes me in there, and now I can sort of step over, and then if I want to step out, then I can. This should be a step out. And now I'm there. So yeah, you have to be careful. Like if I step into, like if I step into print, it'll take me all the way in there. And if that happens, then usually you want to kind of step out like that. Okay. And then if I want to end this little red thing, I can sort of finish it there. Okay. Does that, I mean, that was a quickie introduction, but I think you're. All right. Okay. So my Zoom keeps putting its controls in front of the controls that I want. Okay. Okay, so we're going to spend a while talking about this thing called collections. Now, one of the motivations for this was you notice in the poker, in the blackjack thing, when all you had were arrays. Okay, now those of you, since you're coming, if you come from JavaScript arrays are not like, they're not as nearly as OCD as Java arrays. Java arrays are fixed in size, and you can only have one type of thing in them. You're probably used to the idea of, okay, I have an array and I want to put some more stuff in it, and I just want to stuff them in. You may have noticed that in the blackjack problem, when I wanted to add a card, I had to make a copy of the array, make a new array with one more, copy the new ones in, and then they add the new card. And you may have felt, well, this is a pain. And you're absolutely right. In other words, if you're in a situation where I want something to be an array-like thing, but also expand or contract as I want, as JavaScript arrays do, then I want to be able to do that. And so in Java, instead of using arrays, you would use one of these collections. Now, one of the things that Java has that puts it way beyond all of the scripting languages that I'm aware of is this collections framework. And this is actually a portion of what's available. What Java offers out of the box is an extremely rich and varied and very effective set of abstract data types, is what it's called. In the old days, and they still may do this, and if you're in a pure computer science curriculum, there would typically be a whole course on abstract data types. And in the course of that, because the languages didn't directly support it, as students, you would be kind of writing your own versions of all this. In Java, they actually, in C++, kind of before Java, they had, they realized that was something that languages should support. And now C++ never directly supported it, but they had this add-on called the, I'm blanking on the name, but they had an add-on that kind of did it. And it actually kind of, at least back when I was writing in C++, it never completely, a standard template library was called, and it never completely worked the way you wanted it to. Java nailed it, in my view. Okay, but in order to understand what all this is about, there are, we see that there are interfaces and concrete implementations. So this is just kind of the overview. So the idea is this, is that there are, we're going to be focusing mostly on 3 of these, but we will at least be touching on all 5 that are listed here. At the very bottom are 5 concrete classes. There's something called an array list, a linked list, a hash set, a linked hash set, and a tree set. The book talks about a number of other ones, including queues and stacks and other kinds of things that we won't be touching on, because these 5 here cover all of that. So the book has ones that we're not going to be covering. Here's the thing, is that when you're using one of the, well, first of all, these provide the kind of capability that would have been nice in that blackjack problem. And I deliberately tortured you with that, in part to give some motivation for why to learn about these collections. And we're going to spend some time on this, because this is one of the main advantages of a language like Java, because they let us use both the type safety, we can exploit both the type safety of Java which is not provided by the scripting languages, as well as the ability to have things that hold our objects and can expand and contract without us having to worry about it. In other words, they expand and contract under the hood. Just as in JavaScript, you didn't worry about how the array was expanding or contracting when you put stuff in and took things out. You didn't have to worry about it because that was all done for you. Likewise, here in these classes, Java does all that for you. So you can put stuff in, take stuff out, and not worry about how that's happening. What you do need to think about, though, and maybe worry is kind of too strong a word, but there are a couple of other considerations. One is what is the relationship between the contents of these? How are they going to be stored? Well, you don't have to worry about how, but how from an abstract point of view. Here's what I mean. In a list, okay, so the main two types are lists and sets. Okay, what's the difference? Okay, a list is like you can think of a list like an array. So with an array, and you can kind of use what you had done in JavaScript with arrays to sort of think of this. So if I just added something new to the list, it got put on the end. If I add something else, it got put on the end. So the list arranged things in order. And like an array, I can refer to them by index. In other words, lists have indices. So I can say, give me the fifth element or give me the third element. I can also say, well, as with all of these, I can say, notice that up here, since everything is a collection, and again, this is an interface, I can always ask something, okay, what's your size? I can also add something. So this add method, which you notice is in italics, which means that it's abstract here, is concrete in every single one of these concrete ones. So what this list is a sub interface. So notice that list extends collection, but again, as an interface that means that it extends the collection and it adds some other methods. But an array list implements the list, which means that the array list is a concrete class, and so I can actually use it. Now there's another list called a linked list. Now you all know what a linked list is, right? Maybe? Does anybody not know what a linked list is? Well, why worry about that? Well, why use one or the other? Well, the default is usually an array list, because if I'm using something like this as if it were an array, then an array list is a good place to start, because an array list is very efficient for everything except if I want to remove something from both ends or add something at the beginning. So in other words, an array list it's like an array. And when I add things, it kind of puts them on the end and it expands as needed. Again, an array list is really the closest analogy in Java to an array in JavaScript. I put something, I add something, it goes on the end, I take something off. Well, to take something off is where it gets tricky. If I take something off on the end, that's pretty efficient. It just kind of pops it off the end, no problem. What if you take something off at the beginning? So what if I have an array that's an array list that's, let's say, has 1 million elements, and I want to remove element at index 0. Well, what has to happen? Basically, everybody has to shift left. So 1 has to become 0, 2 has to become 1, 3 has to become 2, etc. Okay, so that's a lot of work. If I know I'm going to be doing that, then a linked list is a better thing to use. Why? Because with a linked list, it's just as cheap to remove something or add something to the beginning as it is to add it or remove it from the end. Just because of the way that it's structured. And we can talk a little bit about how the linked list, when we can talk a little bit about how the linked list is organized. Okay, so the main thing about a list is that it's like an array. And like an array, I can refer to things as by their index. The other thing is that I can have duplicates. Again, think of an array. In an array, I can have the same value in different places. And that's fine, because it's like an array. Okay, but here's where it gets interesting, and that's with a set. Now, if you remember from your mathematics classes, you remember what a set is in mathematics? Vaguely? Yeah. Okay, here's the thing about a set. A set cannot contain duplicate elements. Okay, that's an important thing to understand. A set cannot contain duplicate elements. The main sort of default set that is typically used is something called a hash set. Okay, why is it called a hash set? Because it uses something called a hashing function to very efficiently store its contents. There are two consequences of that, though. In a set, there is no, just a set by itself, there's no natural order to things. In other words, if I have a set of things, I can't say, give me the third one. There's no such thing as the third one. The second thing is that I cannot have duplicate elements. So if I had a set that had 3, if I put 3 on a set, and I put 3 in a set again, I only have 1 3. I don't have 2. Whereas on a list, if I add 3 twice to a list, I have 2 copies of the 3. Now the linked hash set that is useful to at least know about, I'm not sure we'll use it that much, it's kind of like a cross between a linked list and a hash set. It actually uses the hashing, but it also keeps these links so that I can actually step through in a particular order. So a linked hash set will actually keep things kind of in the order that I add them, with the caveat that I can't have duplicate elements. And one of the most useful sets, though, is a sorted set. So notice that here's another sub interface called sorted set. And the Java just has one implementation of that called a tree set. And what that is that's an extremely efficient way of keeping the contents of that set in sorted order. And that can be very useful, because a lot of times you want to sort things. So rather than just kind of putting them in a pile and then sorting them, when you put things into a sorted set, in particular a tree set, it keeps them in sorted order, although that's almost true. It actually keeps them in this funny tree-like order, but when I go through them, it will always give them to me in a sorted order. Now, how does it know how to sort them? Well, that's something we're going to talk a lot about. Okay, so delving a little bit more into some of the details here, and we'll see code examples of this. I'm looking at the time, and I'm not sure if I'll have time to do some code for you today, but there'll be lots of code tomorrow, if not. Okay, so a list interface, again, list interface. Okay, if I have something that is a list, When I say add, it appends it to the end, expands it if it's necessary, and I can refer, insert, or remove items by index. So meaning I can say, give me the third element. I can say remove the third element, in which everybody to the right of that third element has to kind of move down by one. Or I can insert. I can insert. Let's say I can insert it at index 4, and that means that index 4 goes to 5, index 5 goes to 6, etc. So you see that that insertion is kind of inefficient, but can be done. A list can contain duplicates. So and it's the time to do these things needs to be kind of taken into account. In other words, when we're using these, you need to think of, okay, what am I going to be using this for? So an array list is like an array. And in fact, under the hood, it literally has an array. You don't have to know this, but just for your information, what it actually does is under an array list keeps an array of these things. And when you add something, it keeps an index that kind of points to the next one, kind of like what we did in the poker deck. And whenever you add one, it says, okay, I'm going to add at that next index. If you run out of room in that array, again, remember that array is just going to have a fixed size. When you try to add, what it does is under the hood, it just builds a bigger array and copies it in. Pretty much what you did with the blackjack thing, except it only does that when it runs out of room. So you can remove. I can add or remove from the end in constant time, but it takes linear time to remove from the head. In other words, if I want to remove item 0 at index 0, again, it's linear in the number of items, meaning every item has got to shift left. Okay, that's a lot of work. Whereas the linked list, I can add or remove from the header, but you know what I mean by the head or the tail. So the head would be at index 0, the tail would be at the very end. So for a linked list, I can remove or add from the head or the tail in constant time. And for a linked list, inserting is also fairly. It's a little bit more involved, but again, more efficient typically. Okay, the set interface cannot contain duplicates. So what add does is add, and this gets it can be confusing, because an add, if I try to add something, it will only add it if the item is not in the set. If the item is already in the set, it will not add it. There's no concept of index. And again, if you take these and you kind of say print them out, one of the nice things is that these are objects. So as objects, they all have a toString. Unlike arrays, when I print any one of these collections, it will print the contents of it in kind of a nice way. But if I have a set, and we'll see examples of this, if I have a hash set, it will print them in an arbitrary order. Why? Because of this thing called a hashing function, which you don't have to worry about. Again, in the old days, we had to worry about it because, in fact, in the old days, we had to write our own hashing function, which was a real pain in the butt. But because of that, it has to do with the efficiency with which hash sets work. The linked hash set will keep your items in order that you've added them, but there are still no duplicates. Okay, so that's just an important, again, the main difference between a list and a set is a list has a concept of an index and can contain duplicates. A set does not have a concept of an index and it cannot contain duplicates. And again, we're gonna circle back. We're gonna delve, hopefully fairly deeply, into each of these, because this is especially those of you who've been chafing at Java's arrays and saying, well, you know, in JavaScript it was real easy. I just kind of added stuff and I didn't have to worry about all this array stuff. Those of you who've been kind of saying, gee, it would be nice to have a JavaScript-like array. Well, here they are. And in fact, here they are, and there's even more, but wait, there's even more, because this sorted set is one of the most useful things out there. It's like the set, but it keeps the contents in a sorted order. The actual internal structure, it depends. Again, if you were to kind of look at how it's actually storing it, it stores, they use something, it's called a red-black tree. You don't have to worry about that, but it's an extremely efficient way of keeping things in a sorted order. And there's literally been decades of research and computer science about what's the best way to kind of keep things sorted. There's still people coming up with fancier and fancier things. My experience has been that that what Java uses in their tree set is about as good as it gets. So when you add something into a sorted set, it inserts it in a way that preserves the order, and in fact guarantees that the smallest item is always at the top. So for example, if I had a bunch of things and I wanted to oh, you guys are good. Sorry. Okay. So let's say I had a pile of numbers, and I wanted to store them, but I wanted to keep them in sorted order. Well, I could just dump them into a sorted set and then say, give me the best one, and it will just give it to me. If I want to say, okay, I want to step through all these items, and regardless of the order that I added them in, I want to make sure that I go through them smallest to largest. It'll give it to me. Now, in order to do that, you think of, you know, how do you sort things? You know, like if when you play a game of cards, I mean, how do you sort things? Well, a tree set does it a little more efficiently, but basically, let's say if I gave you a bunch of cards that had numbers in them and say, okay, here they're all mixed up, but I want you to put them in increasing order, you'd basically have to be able to look at two of them and say which one is bigger. So in order to, what that means is not every object can be put on a sorted set. Their contents have to be able to compare. I have to be able to say, is this one bigger than that? Or is that one bigger than this? Okay, we'll circle back to that, but just since I only have a minute here, again, unlike JavaScript arrays where I can put anything in it, in these I can only put in certain things, and that's the term is generics, and that means, so for example, if I want to define a list which only contains strings, then I say list and I say bracket string. Let's say I want a set that can only contain integers. I say set, and that is the integer. Now, notice this is not int, it's the capital integer, and we'll talk about what that is about. The reason for that is Java collections can only contain objects. I can't put primitives in, but I can. It just, they don't go in as primitives. They go as a wrapped object. And what Java originally, they didn't do this, but then people kind of complained. And so Java does something called auto boxing. And what it does is it converts the primitives. So for example, in this set of integers called values, this I can say add. I can say add the number 42, And under the hood, what it does is it converts the int 42 to the object integer 42, and then it adds to the values. And likewise, when I take it off, if I take it off in the context of an int, it will take it off as an object integer and then convert it to a primitive int. Again, we'll see examples of that, but not today. We will see examples of that tomorrow. So that's it for today. And again, watch the space for information about the exam on Friday. And yeah, and that's about it. So if there's no more, that's it for today.
Thanks, sir.